All right, hello, my name is Todd Gayley, and I'm here today to talk about Paclets and Paclet Development. This talk is long overdue. The Paclet system has existed for years and been used to great effect within Wolfram. Users have noticed this, and they've been clamoring for information about how it works and how to use it. I'm happy to say that we are now exposing the Paclet system to users, documenting how to use it. This talk is the first step in that process. So the Paclet system was created years ago originally to allow us to provide updates for data categories like country data, the so-called data Paclets of old, which still exist and are still updated using the Paclet system. But from the beginning, it was designed to handle arbitrary content. Is that 150? All right. In particular, Wolfram language packages, things that we might have called applications in the past and still today. Paclets are heavily used within Wolfram research. We'll talk about that a little more in a second. We're now documenting and exposing the system. We are going to be creating a Paclet repository that will accept user submissions. And we're very much hoping to create a vibrant ecosystem of Paclets that are easily discoverable, downloadable, accessible for users. Most modern programming languages have some sort of Paclet repository system, package repository system like that. We're hoping to create something like that for Wolfram, and we're very much hoping that developers like you will help us fill this out. All right, so if you are creating any kind of add-on content for Wolfram products that doesn't fit neatly into one of our other repository categories, if you have a single function repository is the great place for that. But if you have a larger piece of functionality, we definitely want you to create it in the form of a Paclet. All right, so just quickly, some of the ways we use Paclets within the Wolfram system. We componentize the product and build system, and it's very convenient for the build system as well to build a whole bunch of different components separately and then organize them into the product. It allows us to push out immediate updates to functionality that changes much more rapidly than Wolfram product releases. A great example of that is the Wolfram Cloud. Wolfram Cloud changes all the time, and that necessitates changes in the client, the mathematically in-product client of the cloud. So we're constantly pushing out updates to the cloud object Paclet that support the client side of cloud communication. Critical bug fixes, we've used it quite a bit for pushing out critical bug fixes after releases. I mean, most people don't even realize that we do that. We quietly slip those things out onto your system. We've used it for new functionality that doesn't really need to wait for a Mathematica release. We've used it quite a bit for updating documentation after the fact. There are over 200 Paclets in the Mathematica 12.1 layout, and there's over 2,300 Paclets on the Wolfram Paclet server. Now, that's not 2,300 different pieces of functionality. Many of them occur in multiple versions, but there are 2,300 Paclets on the server. Is this text large enough for people to see? You guys can see that?
But at the back, I'm sure
it's at 150%. It's supposed to be.
I can see it.
Oh, Tom can see it. Tom, you probably know what it says anyway, so it doesn't count. All right. So Paclet documentation. Now, finally, right? This is the thing people really here to see. In the beta that is at this conference, there is no in-product documentation for the Paclet system. I have, however, written a tutorial-style document at that URL that I published into the cloud. It's perhaps a little formatting challenged, but I just wanted to get it down on paper. It's a document that complements this talk. It goes into considerably greater detail about all these topics and things I won't be able to get to in this talk. This is a pretty good opening start in the documentation of the Paclet system. So if you're at all interested, please read that. We will have full Wolfram-style documentation coming in 12.1. All right, introduction to Paclets. It took me a while to get to what they actually are. They're units of Wolfram functionality packaged up in a way that allows them to be easily distributed and installed and updated. And also, when they're deployed, they integrate seamlessly into the Wolfram environment. The essential element of what makes a Paclet is this pacletinfo.wl file. I will call it WL file. It's a hard habit to break because I've been calling it a pacletinfo.m file for a long time. You can certainly name your pacletinfo.m. I'll try to stick with the WL terminology in this, but if I say .m, whatever, it works either way. Which is a very small, simple file of metadata. It describes the Paclet and also describes what it requires from the system, and it describes the ways in which it extends the environment. You take a bunch of files and you throw a pacletinfo.wl file next to it, you have a Paclet. We call the thing in Mathematica or in the Wolfram engine that manages Paclets, updates, installs, and makes them available to the system, we call that the Paclet Manager. All right, so Paclets are versioned. This is, the version number of a Paclet is an essential, probably the most essential aspect of the Paclet because the Paclet Manager always uses the highest version number it finds. Having multiple versions, having a Paclet version be part of its identity allows us to have side-by-side installation of multiple versions of a Paclet. And you probably already do have more than one copy of, more than one instance of Paclet installed on your system. Because one might be, for version 11.3, one's for version 12, one's for one operating system, one's for another. They can live side by side on your layout. Paclets have requirements. Your Paclet info file declares certain things that it requires of the system. It can have a dependent. It can say, I need this system ID, this operating system. I require this version of Mathematica or this range of versions of Mathematica. It can also say I require a certain product name.
Can I do that the other way around with the Paclets? Can I specify that my program should only use a specific version of the Paclet and not one later?
The question is, can your program specify I need a certain version of a Paclet? And there's two aspects to this. This could get into a long side discussion. There's two aspects to this. One is can you ask a certain version of a Paclet be installed? And yes. I won't really show that in this talk, but Paclet install lets you say, I want this Paclet name with this version, and it'll be installed. When it comes time to load it, though, it's a separate issue about, it's a difficult issue, and since Mathematica is this runtime environment that might be long-lived, you might have another version of this code already loaded. Your package is now going to be used by the user, and you say, I need version 3.1 of this Paclet, but the user might have already loaded 3.0 or 3.2 or something. It's a little tricky. There's not a great answer to that question. You can manage the Paclets that you installed, and you can write programs that manage the complement of Paclets that are installed, the specific versions. But whether or not you can guarantee that when you call needs blah, whether you're absolutely sure that that's the only version that you're going to be loading, it's tricky. We're trying to think about a good solution for that. Anyway, so the important point is that Paclets that don't match these requirements are basically invisible. If you do Paclet find, function we'll see later, they won't even show up. Paclets have extensions. So extensions, which we will see in a moment, describe the way, Paclet describes the way in which it extends the Wolfram system. Paclet can declare, I have some palettes, I have some WL code, I have some Wolfram libraries, things like that. And finally, Paclets can be disabled and enabled without deleting them. So if there's a Paclet that's not behaving well, you can disable it. If you are testing something, you want to make sure a Paclet doesn't get loaded, you can disable it, you can enable it later. You don't have to worry about deleting it from the system. All right, so this is basic operation with Paclet managers. Essentially, the fundamental principle is that whenever the user or the system looks for a resource, like a file, the Paclet manager is consulted first. And the Paclet manager says, okay, I will look for Paclets that might have this resource. It finds all the Paclets that have it. It calls out the ones that don't match the requirements of the system. It calls out any ones that are disabled. And it always picks the highest version number and uses that. This is a much smarter lookup than a simple $path-based search. And it's important that the Paclet manager is consulted first. So You see documentation that says Mathematica looks on $path. Well, that's not really right. Mathematica asks the Paclet manager first. And then if the Paclet manager says, back here, if the Paclet manager says, I don't have that, I can't find that file in the Paclet, then Mathematica looks at $path. All right. So by design, Paclets are mostly invisible to users beyond installation. And what I mean by that is that it's essentially a passive thing. You don't actively operate as a user on Paclets. You install them, but once you've installed it, it just weaves itself into the system in such a way that the resources that it has get found through the normal means. I install a Paclet, I just type needs some context, right? I don't even need to care where that context came from. I don't need to know anything about how the system is Pacletized. I just ask for things that I want, and they show up. Documentation just shows up. Palettes, they just show up in the system. I don't have to explicitly know about Paclets and say, okay, give me this from this Paclet. Although there are circumstances in which you might want to do that. All right, I'm going to get ahead of myself a little bit here. But I want to talk about some changes in version 12.1 because there are people here, there's Wolfram people here who have programmed with Paclets, and there are some things that are different. I'm making some significant changes to the Paclet system in version 12.1. First is that there's a whole set of functions that people use to operate on Paclets. We'll be talking about them later. They used to be in the Paclet manager context. They're now moving to the system context to be first-class citizens. But the old Paclet manager names are still supported. So if you've written code that calls Paclet manager backtick something, that code will still work. The syntax of Paclet input files is slightly changed. We're using strings now on the left-hand sides of rules, whereas they were symbols before. But the old format is still supported. Paclets should still work. It's also the case that Paclets in the new format will work in older versions of Mathematica. But this thing in red, which you've probably already noticed, is that I highlighted this because this is where, if anyone has written any code that operates on Paclets programmatically, this is code that might break. The in-language representation of a Paclet is now an expression with head Paclet object. It used to be Paclet manager backtick Paclet. So if you've written code that's operating on Paclets and is expecting to see an expression with head Paclet, you have some code if something is Paclet, that code is going to break. You have to ask if Paclet object is, and that's going to be different in 12.1 and earlier. So if you want code that operates with 12.1 and older versions, you're going to have to write a little if statement. You have to write your own little function that asks if it's Paclet or Paclet object. All right, so the Paclet info.wl file, as I said before, it's the presence of this file that makes something a Paclet. It's a very simple file. You can also name it packinfo.m. So let's take a look at a trivial Paclet info file. Now, I've got name and version highlighted in red here because those are the required fields. Every Paclet must have a name and it must have a version. The name must be unique in the world of Paclets. The version can have, notice the version is a string. It's not a number. It's a string. It can have up to 5-digit blocks, 1.0, 0.5, 0.7, 0.3, or something like that. All right, and the extension section, this is where you tell the Paclet manager what things your Paclet provides. And you can probably figure this out. A kernel extension is the way of saying, I have Wolfram language code. I have contexts that need to be mapped to files in my Paclet. And so you say, so this is Paclet's called file utilities, and I'm saying I export some context called file utilities backtick. Now there's no requirement that this context file utilities match the name of the Paclet or anything of the sort. That will often be the case, but there's no requirement of that. The root arrow kernel thing, when the Paclet manager looks, so someone says needs file utilities, the Paclet manager will say, I know there's a Paclet that has that context. And how is it going to map file utilities back to the full path to the file? Well, it knows where the Paclet is installed, and the kernel extension has a root that says that's a path within the Paclet to the content for this type of extension. So this would be a kernel subdirectory of your Paclet. Now, most extensions have a default root. the typical named place where content for that type of extension would reside. And kernel is the convention. People should write Paclets with their .m files in a kernel directory. But for backward compatibility reasons with old style applications in various formats, I couldn't make kernel the default root. So if you have a kernel subdirectory with .m files in it, you have to say root goes to kernel. For almost every other Paclet extension type, the default root is the place that you would normally put the files anyway, so you wouldn't have to specify root. But for a kernel extension, that is not the default, so you will have to say root goes to kernel. All right, so trivial Paclet just has really one piece of content, a .m file. And this is what the directory layout might look like, as you can guess. You have some file utilities parent directory, which the name of that directory is meaningless. It could be anything. The Paclet is defined by the PackInfo.wl file. And a kernel subdirectory and a file utilities.wl file within that. All right, now here's a slightly more complex PackInfo file. In red, I've got highlighted Wolfram version, system ID, and product name. These are the three fields that let you specify requirements for your Paclet. So Wolfram version goes to 12.star. That means any version 12. In fact, 12, just 12 is the same as 12.star, right? You can always, there's always an implied .star at the end of every version specification. You can also say 12 plus. That would be any version starting with 12 and onward. You can use minus. You can say 12 minus and 12 back. You can have, there's a bit of a small little language you can use to specify your Wolfram version requirements. System ID, that's obvious. So this Paclet would never be installed or used on any system other than Windows or Windows 64. Product name, you can say Wolfram Engine, for example. That we don't really document product names, but our products have different names internally, and so if you had a Paclet that's maybe only appropriate for a system modeler or something, you could use product name to specify that it was only compatible with system modeler. And then you can have various fields, creator description, a support link or something. There's a lot of fields that are described in a PackInfo file, but they really don't have, most of them don't have any intrinsic meaning. You can also have a custom field. I have some custom field here. There's nothing to keep you from creating your own fields in your PackInfo file. All right, so extensions. There's various types of extensions, and the point of these extensions is that you want your Paclet to just weave itself into the system, right? So your kernel extension you've already seen. If you declare your kernel extension, then needs your context will automatically work. A front-end extension, if you have palettes, system, style sheets, front-end resources like that, you just put them in the properly named directory, and you declare a front-end extension, and they'll automatically show up in the front end. Documentation, same way. If your Paclet has documentation, you want it to automatically show up in the help viewer. A path extension is a way to say, I want files within my Paclet to be found as if they were on $path. I'll show an example of that later on. If you have library link libraries, you can just declare a library link extension. You don't have to go modify $library path, things like that. You just declare that you're a library link extension, and then load library will find your libraries. JLink, if you have a Java subdirectory and with some Java classes in it, Java files, JLink will automatically find them if you just declare you have a JLink extension. You don't have to call add to class path. A resource extension is a little different. It's sort of a generic resource of any kind in your Paclet. And there's a Paclet resource function that you use to look up named resources. I'll show an example of that in a second. And you can also create custom extensions. The Paclet manager is not going to choke if there's some extension type it's never seen before. And there's a very good reason for doing that. I probably won't have time to talk about it, but it's described in my tutorial. You can implement a plug-in type system where you can look across all Paclets in the system and say, okay, tell me all the Paclets that have this type of extension. And then you could, if there's some sort of resource that you wanted other Paclets to be able to provide and plug into your framework. All right, so here's a much more complex example Paclet with a bunch of different types of extensions. We have a kernel context, a kernel extension, and it has multiple contexts that it exports. We have documentation front-end path and a resource extension. So if you look at the resource extension, it's just a way, a resource extension is basically just a way to say, I want to map a symbolic name like sun to a path within my Paclet. We'll see an example of looking that up. So you can probably guess this is what the directory layout for this Paclet would typically look like. We've got a kernel directory. It says mypackage.wl. I guess there were supposed to be 2 files in that directory. The front end extension has a front end subdirectory. This front end / palettes, this is just the standard front end layout, right? You just have to conform to the front end, the layout the front end expects. You have a directory called palettes style sheets. And it's the same layout that you see in Mathematica product. The same thing with documentation. I just conform to the standard directory structure that the documentation system expects. And then I have a resources directory. This is for the resource extension. And you saw that had expected an images subdirectory with files in it. So this is what that directory layout maps basically directly to the extensions that we saw a minute ago. All right, so I do actually have this Paclet sitting in a directory laid out on my system. So I'm going to install it just to show how this works. All right, so there's a function in the Paclet Manager called PackPackLid, which takes a directory that contains a Paclet info file and it crunches it together to create a .paclet file. And then Paclet install I can use to install that. And you can see the result is this Paclet object expression, which is a representation in the language of a Paclet. So what has happened now is I had a directory sitting somewhere on my hard drive with some files in it, Paclet info. I zipped it up, and then I installed it. When I did Paclet install, it got put into the Paclet repository, which is often, your $user base area. So now this Paclet is installed, and so I want to show that the resources that Paclet declared are all present. It had a palette called Super Palette. It just showed up the minute I did that, right? This is not an interesting palette, so I won't bring it up. That palette wasn't there before, but it's there now. If I say needs my package and call example function, it works, right? That was a function defined in my package. This is the path extension. I can now use the name of the Paclet as the first component in a relative path. So this basically, it's as if you had appended to $path the root directory of your Paclet. So I can just now say example packet / hello.txt, file gets found. And this is an example of the resource extension. It might be worthwhile to go back. So here I declared that I had a resource extension, which is just arbitrary things that will be found using the Paclet resource function. And I just declared that I had some name sun, which should map to images / sun.jpg. So then in code, I just say Paclet resource. I give my Paclet name, and I give the name of the thing. So this type of declarative programming is extremely useful. In my code that uses the Paclet, I don't need to know anything about the structure, internal structure of the Paclet. The Paclet can change the location of this file as long as the packetinfo.m file changes to properly reflect the new location. Code like this will just always work. I can refer to this thing by a name instead of by its path. All right, so that's just an example of the basics of how these things work. You create a layout, you create a packetinfo file, and when you install it, it's just woven itself into the system so that all the components can be found without any effort. All right, so a brief note about .paclet files. So when a Paclet is deployed, it's just a directory. But a convenient form for distributing them and deploying them is a .paclet file, which is just a compressed archive to a single file. PackPacklet is a function that does this. There's also unpackPacklet. I sometimes hear people say things that imply that they think making a Paclet means creating a .paclet file. It's not true. Making a Paclet means just throwing a .paclet info file into a directory. Now you've got a Paclet. Paclet is not defined as a .paclet file. That's just a convenient mechanism for distributing these things.
Does it have to be single files, or can it be subdirectories with files in them?
Oh, no, your Paclet can have an arbitrarily complex structure. A single Paclet in a single .paclet file, the Paclet itself can be arbitrarily complex. But, I mean, we just saw a Paclet that had multiple directories and subdirectories. But you can only put one Paclet into a .paclet file.
Does it use something like 7-zip, or it uses mathematical?
It's a zip. The question up here is basically about the internal format of a .paclet file. And the answer is it's a zip file. If you change the extension to .zip, you can unzip it. Please don't. Don't use anything but PackPack to create Packlets. You could use some zip utility, but PackPacklet handles some things for like we want. The zip archive convention is not well specified, and so PackPacklet can handle things like preserving the executable bit on programs. It handles Unicode files, Unicode characters and file names and all that. So please use PackPacklet. It also creates a Paclet file, a .paclet file whose name includes the version and the qualifier, and it creates what we consider the proper name for the file. So please use PackPacklet. All right. So installing and updating Packlets. Paclet install is the function that installs a Paclet or updates one if a newer version is available. In version 12.1, Paclet update is going away. It's still supported in the Packet Manager context for compatibility, but the function is going away. Paclet install will do both duties, both originally installing and updating a Paclet. So Paclet install is very fast if no update is available. It generally does not consult. People sometimes think, I don't want to call Paclet install, scatter that in my code because that's going to be really slow. The system has to go ask the server if a Paclet's available. It does not ask the server. It just looks at a local cache of data. Now, I say generally does not contact the Paclet server because the Paclet server gets contacted every now and then, like once in a session for sure. And so it's conceivable that if you call Paclet install, that you might be the guy who pays the cost for hitting the Paclet server. And generally, that rarely happens, but it's not impossible that any individual call to Paclet install might trigger a call to update the Paclet info, which might take a second or something from the server. Almost all the time, however, Paclet install is extremely fast because it does not touch the server in any way, of course, unless a Paclet gets downloaded. And Packlets are installed into $userbase package directory. This location is probably changing in 12.1. I'm not even really mentioning that because you shouldn't care. You should always use $userbase package directory to find where Packlets are installed. Don't assume you know where they go. All right, so here's some various uses of Paclet install. You can pass a Paclet name, and this is the typical way. That would get a Paclet from any server, any Paclet site that's known to your system. You can also install directly from a .paclet file. If I create a .paclet file and give it to you, distribute it in my organization, the users can just install it directly as a path. You can install from a URL if you have a URL that points to a Paclet file, and you can install from a cloud object. This doesn't, some of the stuff I'm talking about only works in 12.1 or maybe even like my 12.1 and not your 12.1. So I can't promise that. I'm describing the Paclet system, as it will be, not necessarily this exact instant in time. This one thing doesn't work quite right. All right, so that's Paclet install. Finding Packlets. Paclet find is the function that finds Packlets on your system. So here I've called Paclet find interpreter. Interpreter is a Paclet. All the interpreter functionality is packaged up as a single Paclet. So there's three things. Paclet find returned 3 Paclet objects. Now, surely I don't have 3 copies of interpreter in the layout. And of course, I don't. So these other instances are elsewhere. These are going to be in my Paclet repository. Did I run this? No, I didn't run it. So the first one, that's the one in the Mathematica 12.1 layout. I have two other older copies of Interpreter in my Paclet repository. So why do I have old copies of Interpreter in my Paclet repository? Well, they were probably updated. They're probably updates for Interpreter in like 12.0 or 11.3 or something like that, right? I still have those copies of Mathematica. I've gotten Interpreter updates for those things. When PackInstall installs an update, it generally deletes the older version. But it won't delete the older version if the older version is clearly not, if the newer version is clearly not a replacement for the older version. If the newer version is, version 12 plus, and the old one is version 11, it won't delete the version 11 one because it doesn't, Packet Manager doesn't know whether you still have Mathematica 11, whether you might still want to run Mathematica 11, so it doesn't want to just blindly delete all old copies of Packlets. But it will if it's seen as clearly an update to an old one. All right, so Paclet Find has a lot of options to control what types of packets you want to find. And I'm not going to go into any of this stuff, but you can ask for packets in a certain location. You can ask for packets with certain extensions. You can ask for packets with certain creators or whatever. There's a lot of ways that you might want to search out Packlets. You can also use simple wildcard notation. This is all the packets in my system that start with N. And again, there's a lot of duplicates here because some of these are in the Paclet repository. The other thing that you might want to do is to look for packets on Paclet servers. PackFind Remote is the function that does that. So if I say PackFind Remote for Interpreter, I see 2. Now, there's 2 Paclet objects with the same number. I think if I run this again, I'll only see 1. Yeah. At the time I ran that, I had 2 Paclet sites known to my system. Most users only have 1, the regular Wolfram public Paclet server, but many people internal to Wolfram, we have other Paclet servers in the company that are visible. They're used for non-public distribution of Packlets. At the time I ran that, I had 2 servers. But I removed that server, so this is just the one that's sitting on the public server. So you might think that a common use people might have is to find out in advance whether an update is available for a Packlet. But there's a utility function that does that PackCheckUpdate. So instead of calling PackFind Remote and seeing if the list was not empty, you can just call PackCheckUpdate. So that's the utility function that tells you whether an update's available. It returns a list of all possible updates. So if it's that empty list, then your interpreter, your Packlet is up to date. Getting information about Packlets. There's a lot of ways to get information about Packlets. There's a Packlet information function, which returns a big list of rules about the thing. You can also use it with a selector like this, where the second argument is the selector that just gives the value that you want. Now this also does not work in 12.0. You'd have to say, location /dot Packlet information. But this selector notation does work in 12.1, or at least, my 12.1. And then the information function, we have this general purpose information function, which is overloaded to work with all sorts of different expressions in language. It also works on Packlets. But to use information, I couldn't say information of interpreter because information, I have no idea what I was talking about. I have to get a Packlet expression, right? So I say, first a Packlet find of interpreter, that gives me the Packlet expression, the Packlet object for the sort of active version of interpreter on my system. And if I say information of that, then I get this lovely little data set type, a representation of all of the fields in the Packlet. Now, it's generally not the case that users really deal with this stuff anyways, right? You don't. Most people have no idea that interpreters are Packlet. They don't care. They don't want anything to know about it. But there are times as a developer, especially when you do want to sort of programmatically ask questions about Packlets. Jesse.
Will the first part of the return value for PackFind always be the active version?
Yes. Well, yes. That's a good question. Yes, PackFind is sorted in order of version number, and the first one is the highest version number. But to be strict, That's not strictly true because by default, if I say Paclet find, it only returns enabled Paclets. It only returns packets that are visible to my operating system, things like that. But there's options you can use to Paclet find to overrule that. You can say enabled arrow false, and you can see all the packets that are disabled on your system. And so in that case, the first one is not the active one because none of those packets would be active, but it's always sorted in version number order.
Is there a way to find out which Paclet implements a function?
No.
No.
There's no built-in way because that's essentially well below the concern of the Paclet Manager, right? The Paclet Manager just knows about, you tell me about your context. Paclet Manager doesn't probe into, to figure out what function is available in which context. I mean, what you can do is you could, if you know the context the function is in, which is easily done, you could say Paclet find and then context arrow that context, and then you'd see the packets that supply that context. So you sort of do it as a two-step thing.
And I'm sorry, how would I know which context?
Well, you just say context of some function, right? There's a function in this built-in language. It gives you the context. All right, Paclet Sites. So when you call it PackInstall or PackFind Remote with a Paclet name, the Paclet Manager looks for that Paclet in the set of known Paclet sites. Like I said before, most users just have one known Paclet site, which is our Wolfram public Paclet server. But Paclet Sites is the function that returns the list of known Paclet sites. So we get this Paclet site object expression back. You can use Paclet Site add and Paclet Site remove to manage the set of known sites. The set is persistent from one session to the next, so it's sticky. So you don't, once you add a Paclet site, it sticks around until you remove it. So the reason to call Paclet Site add is if your organization, or you or whatever, wanted to create your own Paclet sites, distribute packets within your organization, say, then you would have people call Paclet Site add to add that site, and then they could get packets from that site. And I'm going to show an example of this. I say this is easy to do, so I better back that up. So I have a quick demo here of setting up a Paclet site. It is, in fact, easy to set up a Paclet site because there's no logic required on the server side. Our Paclet server has a little bit of logic, and logging and things like that, and checking stuff, but it's not strictly necessary to have any logic at all on the server side. A Paclet site can be as simple as a web server. It's a simple web server, or it can be just a file, a shared directory, and that is the example I'm going to show. So here I have a directory. I don't know if you can see this, but there's a directory called Paclets, and I've thrown a few Paclets in there. It's a random set of packets I had kicking around on my machine. So this is going to become my Paclet site. I create a Paclets directory, and I throw in all the Paclet files, the .Paclet files that my organization has created, or whatever that I want to make available to users. Then I call this function called build Paclet site files in the Paclet Manager context. This is not a system function. You have to dig into the Paclet Manager context to get it. I just point at that Paclet site directory. Now what this does, it creates these two files, pacletsite.m and pacletsite.mz, which is just a compressed version of that file. That's all that's required to set up a Paclet site. And if I go back to my directory, you'll see now that pacletsite.m and pacletsite.mz have been created in that directory next to the Paclets directory. So I now have a Paclet site. I'm going to say Paclet Site add, and I'm going to call Paclet Site update because, and this is, I think, obviously a miss feature because every time I do this, Paclet Site add does not call Paclet Site update. Paclet Site update is the function that says, okay, give me the cache of your data so I can store it locally. And Paclet Site add, I think when I wrote that, I think I was originally thinking that you'd want to be able to add some sites and not have to touch them all right then. But you always have to immediately call Paclet Site update after you call Paclet Site add. So I think I'll almost certainly make Paclet Site add call Paclet Site update internally. because even when I was coming up with this talk, I did Paclet Site add, and then I tried to use it, and I was like, the Paclet's not there. Of course, I've done it enough times to immediately realize I didn't call Paclet Site Update. So I call Paclet Site Update. That lets my system know about the files on that site. And now if I say PackFind Remote Minecraft link, now there's two here. The 1027, that one is actually on the public server, right? It's this 1015 version that is on my Paclet site, my local site. And if I, once again, if I do, the location selector on these, see, one is on packetserver.com, the other one is at this file URL. So if I did PackInstall Minecraft link, I'm going to get the 1027 from the public server because that's the highest version number, but you get the idea. If there wasn't a higher version on the public server, then any calls to PackInstall would get the one from my local site. So that's it. So all you have to do to create a Paclet site is just put a bunch of files together in a package directory, run that build site files function, and then figure out a way that users can see it. I've done this just with the file URLs, but I could easily have just any old web server running and just expose that directory via the web server, and then users would just say Paclet Site add, and they'd give the URL to that directory, and it would work. So it is actually very simple and very feasible for organizations to create their own Paclet Site as a distribution mechanism for Packlets. I mean, the great convenience of that is that you don't have to, yes, you can put Paclet Site .Packlet files in some place and tell people to get them. But it's very convenient to be able to refer to Packlets by name, Paclet install my Paclet. And for that to work, it has to be on a Paclet site. All right, so developing Packlets. Well, Packlets do often have a simple layout, and they're easy to create by hand. I've been creating Packlets by hand in this talk, or at least pre-created Packlets by hand. Use your favorite IDE or editor to edit the whatever files you've got. Just put them in a certain layout. But Wolfram Workbench is a great environment for Wolfram language development, and it does have built-in tools for Paclet development. Tools are a little bit out of date. They were created many years ago, but updates are pending. And I still recommend that people use Wolfram Workbench. You have to understand Packlets to use Wolfram Workbench because it isn't really going to hold your hand perfectly. Right, well, that's what I'm talking about. Wolfram Workbench is the Eclipse plugin. That's our name for the Wolfram Eclipse plugin. And so I was just saying, it does, and we're going to work an example Paclet in just a second in Workbench. But there is lots of room for developers to create tools and plugins to assist Paclet development. And here's some ideas. Automatically create a Paclet info file from a directory. You could pretty well look at a directory and say, I can figure out what this Paclet should look like, right? You could verify the syntax and completeness of a Paclet info file. You could automatically create a basic directory layout, create Paclet structure, kernel or something like that. And it would create a basic Paclet structure for a kernel type Paclet. There's already a function called Pacletize in the function repository that creates a very simple Paclet out of a function definition. So we're really hoping that people will run with this and create tools and things that help simplify the process of Paclet development. All right. Authoring and building documentation, this is the bugaboo, right? This is by far the most complex part of Paclet development. And the reason for that is that the documentation that ships with Wolfram products is authored in a very specialized format. And then it's processed by a tool to create the in-product format. And the authoring tools are highly specialized for Wolfram research processes. And the processing tool is also highly specialized. And so we definitely want authors of Packlets to be able to create documentation that looks like Wolfram format. And to do that, you really need to use this pipeline, or at least tools that we give you that run the pipeline perhaps in some simplified version. And such tools are coming. But at the moment, we don't really have that solution. So we are working on a Paclet with the tools that you need. I wanted to try to show it here today, but it's too complicated. It's not my area. I thought I could throw something together, but it defeated me in the short time that I had to try to pull that together. But in the meantime, you have two choices. You can use Wolfram Workbench.
Are you, when you have that working, are you going to have the ability to fix some of the issues with documentation for company packages, such as the URLs post point to the Wolfram website for the documentation, and if you were doing your custom packages that is broken?
I'm sure, I mean, that to me sounds like a bug that I can't promise will be fixed in the first, I mean, we will create a tool that's supposed to do it right, and there may be a tail of adding features and fixing things that people point out. That's kind of that's an issue that would obviously need to be fixed. But if you say there's a bug now, we'll have to make sure that that bug gets fixed in the tool, right? But another alternative is to not use the Wolfram documentation format. Now, I hate to say this because we really want users to use the Wolfram documentation format. We can't really tell you to use the documentation format and not give you tools to create it. But you can just author notebooks in whatever format you like, and if you put them in the layout in your documentation directory in the layout that matches the expectations of the system, and this is discussed in more detail in my tutorial document, they'll just work. They won't look quite right in the documentation system, but they will function. We don't really want people to do that, but it is a good stopgap until the tooling is better. I think this is my.
When you say specialized tools, these tools you built in-house?
Yeah. This would be, we'd love to have a PackLid called something like, Paclet documentation tools. They would have functions that would let you say, they would have a palette to help you author in the correct style. They would create default empty pages for various times. Here's a blank tutorial page, here's a blank function page, a blank guide page, and that you could edit those, and then it would crunch them into the in-product format, that sort of thing. All right, so let me go to Workbench here. I'm going to build a Paclet in Workbench with documentation real quickly here. So here's Workbench. Now you may not be able to see this, but you get the idea.
Updates are coming to Workbench. Would that be 12.1?
Well, the Workbench updates would be on a different release schedule, right? They're not tied to Mathematica releases, so it's just a question of when we get around to making some tweaks into Workbench.
There's no timeline.
I don't have a timeline for that. All right, so I'm going to say File, New, Other. Now because I have Workbench installed, I have this Wolfram category. So I'm going to say Application Project. Really should say Paclet Project. So step one, you have to know that this means Paclet Project, right? So I will say Next, and I think I'll call it My Paclet. I think that was what I decided. It's got the right thing. It says create Paclet info.m. I want that, and create documentation. I want that. I don't need a test notebook for now. All right, so I say OK. So now it's created this Paclet layout. Now, one thing about this is that the Paclet info.m file is sitting next to the My Paclet directory. That is not the modern style. I want it to be inside that directory, so I'm going to put it in there by hand. So now this is the Paclet directory. It's got a documentation subdirectory, a kernel subdirectory with a .m, with an init.m file in it, and a Paclet info.m file alongside of it. And Workbench has a Paclet info editor that gives me fields for doing this. I'm going to just, for the moment, click this tab so I can just see the raw text. So here is my stock Paclet info. I need to say a kernel extension, right? Well, I'm not going to. Let's just say this is not really going to be a functioning Paclet. I'm doing this really for the documentation. So I create a kernel extension with a context. Now, there's an issue about the layout of this thing. The mypaclet.m file is not in the kernel directory. There's this init.m file in the kernel directory. Just a quick note about init.m files. They're evil. Never use one. Init.m files have no place in the Paclet world. It's kind of a hack that was created years ago to fix an issue about path lookups. You should have no need for an init.m file. The Paclet manager you tell the packet manager where your .m files are, and so, but this creates a kind of an old style layout with a kernel and init.m directory. Really what we want is to put this in here. And then get rid of this. See, these init.m files have this double pack, get my Paclet back to my, it's just an ugly thing. We don't have any need for any of that. All right. I need to say root arrow kernel in this extension here, but I'm not going to bother with that because I don't care. I'm not actually going to run the .m file. All right, so now, see this documentation tab down here? So Workbench has tools that actually work nicely to create regular, real Paclet documentation. So I'm going to click on my symbols directory. I'm going to say add page. So let's say I had a function called myfunc or whatever. I don't care about them, right? So I say add page, and crunches away, and there's my myfunc page. And I can create a new guide page if I want. Crunches away and creates it. And you can see that in here, those files are showing up now. I got a guides and a reference pages symbols thing. So I didn't have to know anything about the layout of these pages. And so I have these stub pages. And if I open them, if I open this in Mathematica, it takes a minute to launch here. So you get, this is what it looks like. Now there's a palette in Workbench called Documentation Tools. It has this silly dynamic warning. It's a little palette there I can use to, there is this documentation for this palette format and how it works in Workbench. So I can edit this file and build a standard looking documentation file in Mathematica. I'm not going to do that. So when I'm done with my documentation, there's this application tools tool here, and I'm going to pick my project, which is my Paclet. And I'm going to say build. And it crunches away. It takes a little while. It's just 2 files. It takes a little while. Are there any questions while this is running?
How does it scale? The time it takes to do this, how does it scale with the number of files or the size of your packet?
Well, this will be linear with the number of documentation files. I don't know how it scales with the size of the file. I mean, presumably it's just linear with the size. I mean,
Even for little tiny things, it takes a long time.
yeah, it takes a while to do. I mean, it's just, okay, the build is finished now. It took 25 seconds. Most of that was the processing of the documentation. So my Paclet is now, it's built. So if I went back to Mathematica, I just have one, really, this is practically my last slide here. Packet directory add is the function that tells the packet manager to look for packets in a non-standard location. And the reason you use packet directory add is extremely useful for developers, not useful for users. The reason you use packet directory add is what I'm doing right now. I have some development directory from my Paclet, and I'm editing the files in place in the layout of the Paclet. And I want to be able to just go back to my Mathematica session and say, get my context, and load the changed file over and over again, right? So I need to tell the Paclet manager, look for Paclets in this directory. So I say packet directory add for my development directory. And now I can just go back to Mathematica, and everything in my Paclet will just show up immediately, just as if I had installed the Paclet. You don't want to have to pack and install your Paclet somewhere else just to see the last little edit you made to the .m file. This is very much like the analog of prepend to $path in the non-Paclet world. Yeah.
Is there an equivalent to $path?
No, there isn't. The equivalent to
I mean, just something to see your packet directories.
there.
To add or
Oh,
remove.
I see what you're saying. Packet directory add returns. There isn't. I should probably add that. I think I may. There isn't a way to see the set of added packet directories. Packet directory add returns the set, but there isn't actually a function now that just tells you it. I should probably add that. Okay. I just might make packet directory add of no arguments return the list. Yeah.
So is it a
got to say.
Paclet in that Paclet directory has the same version as the one that's in some other Paclet.
All right, very good question. The question is, does it? And the answer is yes. This is very important. Paclet directory add wins ties, and this is very useful if you have a version of my Paclet installed somewhere else. It's in the layout maybe, or it's installed in a repository, version 1.0, and I'm working on the new version, but I haven't added to the Paclet info file to make it version 1.1. If I say Paclet directory add, it will, my version 1.0 will be found ahead of the one anywhere else. So Paclet directory add wins ties in terms of version numbers. Right. Now, I've run out of time. I was going to show, if I point at this Paclet I just built in Workbench, the docs will show up in the system, just like you'd expect. But I don't have time to do that because I've run out, but I just want to mention briefly this Paclet repository. So we do have a Paclet repository under development. We really want to create a thriving collection of Paclets. Something like PyPy, NuGet, every language has this type of package repository, and we want to create one of our own, and hopefully we'll have lots of submissions, contributions, and people. So go forth and create Paclets and help us grow the Wolfram system. Thank you very much.